Hello and welcome to the YouTube channel SAP on Azure. My name is Martin Mertes, and in this video I want to show you how to copy an Azure resource group using the open source tool RGCOPY. Before starting, I want to introduce myself. I'm a software engineer working for Microsoft since 1996. For SAP Business Warehouse, I have been developing all the SQL Server related ABAP code. This code has been released by SAP from 2009 until now. For Azure, I'm part of a team that created a test framework for SAP HANA and NetWeaver workloads. Here comes RGCOPY into play. Initially, I developed RGCOPY as an internal Microsoft tool used by the test framework. In the meanwhile, it is available as an open source tool on GitHub. In this video, I will show alternating slides and live demos. Let's start with an overview slide. RGCOPY can run in three different modes: copy mode, update mode, and archive mode. By default, RGCOPY is running in copy mode. This is used for copying the resources of a source resource group to a new target resource group. The source and the target resource groups can be in different regions and subscriptions. The two subscriptions do not need to use the same tenant. Means the used Azure accounts might be stored in different Active Directories. RGCOPY does not change any property in the source resource group. However, you can define in RGCOPY that resources are deployed with different properties in the target resource group. In update mode, you can change resource properties in the source resource group. This is very useful when you have resource groups that are used very seldom. To save costs, you can stop all VMs while they are not used. However, you are still charged for the disks. Using update mode, you can easily convert all premium disks to standard SKU and all NetApp volumes to standard service level. In archive mode, a backup of all disks is created and stored as cost-effective blobs in a storage account of a backup resource group. No resources are deployed in archive mode. However, RGCOPY creates an ARM template that can be used later to restore the resource group from the block backup. This ARM template is also stored in the storage account of the backup resource group. Let's start the first demo. RGCOPY is a PowerShell script that requires at least three parameters: source RG, the name of the source resource group; target RG, the name of the target resource group; and target location, which is the name of the region used for the target resource group. There are different ways passing parameters in PowerShell. This is the easiest way. However, this can become illegible when using many parameters. Therefore, you could split the parameters into lines using a space followed by a tick at the end of the line. Then the command looks like this. For RGCOPY, I prefer another option that is called splatting. Hereby, you firstly create a PowerShell hash table variable and then pass this variable to the PowerShell script. This looks like this. Note that PowerShell variables start with a $sign. However, the variable must start with an @ when using it for splatting. Let's run RGCOPY now using these parameters. RGCOPY always creates a log file that contains exactly the same data as seen on the screen. At the top of the log file, you can see all used parameters. Below, there is a note on the RGCOPY online help. Let me demonstrate the online help. Therefore, I copy the command and paste it into a new tab. Starting the Get Help opens the browser and shows the online help in GitHub. The help is quite comprehensive. For searching in the help, you could use your browser search. Another way is using GitHub headings for directly selecting a chapter or a section. There's also an offline help integrated in PowerShell. However, this only shows you the parameter names of RGCOPY. Let's have a look at the offline help. As you can see, RGCOPY supports a lot of parameters. But don't worry, you do not need to know all of them. You could even start RGCOPY without any parameter. In this case, you will be prompted for all mandatory parameters. While this is running, I want to show you how to install RGCOPY. First of all, you have to install PowerShell 7. The minimum version required for RGCOPY is currently PowerShell 7.1. However, I would always install the newest version. In my demo, I also installed Windows Terminal. Hereby you can use multiple tabs in PowerShell. RGCOPY requires some PowerShell modules dependent on the used RGCOPY features. In most cases, PowerShell module AC is sufficient. RGCOPY will tell you if additional modules are required. The most important step, of course, is downloading the newest version of RGCOPY from GitHub. Just store the file on your PC in a local directory, typically the home directory. That's it. RGCOPY is installed. You can run RGCOPY on any machine that supports PowerShell 7. That is Windows, Linux, Macintosh, and even Azure Cloud Shell. In Azure Development, we are running RGCOPY most of the time inside a Linux container. Even though RGCOPY is already installed, one last step is missing before running RGCOPY. You must authenticate yourself at your Azure subscription. Therefore, you can use the Connect AC account commandlet. When running it, a browser window opens and you can enter your Azure credentials. After that, you can start RGCOPY without any password. RGCOPY is using the Azure credentials that are cached in PowerShell for a while. RGCOPY works fine with Azure user accounts, service principals, and even with managed system identities. You can even use different Azure accounts for the source resource group and the target resource group. In this case, you must run Connect AC account 2 times before starting RGCOPY, one for each user account. Let's go back to our demo. As some might have already suspected, there is no resource group AA. Therefore, RGCOPY terminated with an error. The RGCOPY log file contains the call stack once an error occurs. Well, in this case, the call stack is quite small because the error occurred in the main program of RGCOPY, not inside a function. The error message should be clear. If not, you can have a look at the source code of RGCOPY. In this example, the error message was triggered in line 12,924 of RGCOPY. Once RGCOPY finishes, with or without any error, a zip file is saved that contains all files created by RGCOPY. To enable automation, RGCOPY creates an exit code. Exit code 0 means everything worked fine. In case of an error, exit code 1 is used. Before further analyzing the output of our first example, let us have a closer look on the workflow of RGCOPY. RGCOPY consists of 7 main steps. Some of them are only needed in special cases. For simplification, I only show the 4 most important steps here. The first step is creating an ARM template. Therefore, the ARM definition of all resources in the source resource group is exported to a file. This ARM template is then modified by RGCOPY in order to change some resource properties. The next step creates the snapshots for each disk in the source resource group. This is typically the only modification that is performed by RGCOPY in the source resource group. The snapshots are created in parallel, independent from each other. RGCOPY does not know whether files on the different data disks belong logically together. For example, data files of the same database might be stored on different disks. Therefore, RGCOPY does not allow creating snapshots of running VMs with more than one data disk. This is a safety feature to avoid data inconsistencies in the target resource group. In this case, you must stop the VM in the source resource group before running RGCOPYs. VMs with just one data disk can be copied while they're running. Create blobs is an optional step. If you are copying to a different region or subscription, then the ARM template cannot use the snapshots directly. Therefore, a copy of the snapshots in the source resource group is created as blobs in a storage account of the target resource group. This copy process can take quite a while, in some cases even longer than a day. If the copy process just fails for a single or a few blobs, then you do not need to repeat everything. RGCOPY has some parameters that allow to continue a failed blob copy process. The last step is deploying the resources in the target resource group using the created ARM template. Keep in mind that this automatically starts all VMs. However, there is an RGCOPY parameter that automatically stops these VMs again after successful deployment. Let's have a look at our first demo again. In the meanwhile, RGCOPY has finished successfully. We can now double-check the log file. Therefore, I'm scrolling up to the top of the log file. As you can see, the log file is quite comprehensive. As already mentioned, everything you see on the screen is also written into the log file. RGCOPY has been started with 4 parameters. The first 3 parameters are of type RG, means resource group. The parameter setVMSize is a resource configuration parameter. This kind of parameters is very flexible because it can use different data types. Let me show this on different tab. The data type of a resource configuration parameter is a string or an array of strings. Each string represents a rule. In the first example, for setVMSize, we are using a string as a parameter value. Means we have one rule. This setting results in changing the size of all VMs. In the next example, the rule contains an @ followed by a VM name. Therefore, only the size of this specific VM is changed. In the next example, 2 VM names separated by a comma are specified. Therefore, the size of these two VMs is changed. Exactly the same happens in example 4. However, we are using here an array of 2 rules instead of a single rule. In the last example, we have 3 rules. The first rule defines the size of VMs HANA 1 and HANA 2. The second rule defines the size of VM SAP app. The last rule does not contain a VM name. Therefore, it is valid for all other VMs, where no specific rule exists. There are lots of other resource configuration parameters besides setVMSize. Let's have a closer look on them on the next slide. In this slide, I want to show you the most important resource configuration parameters. We already have seen the VM configuration parameter setVMSize. Using setDisk caching, you can configure the host caching and write accelerator. Technically, this is a configuration of the VM. Logically, we configure it per disk. In addition, you can configure the following disk properties in RGCOPY: disk size, disk skew, disk performance tier, and disk bursting. Parameter set disk max shares enables a shared disk and configures the maximum number of shares. Some RGCOPY parameters have default values. Hereby, all disks are created as premium disks in the target resource group, and accelerated networking is turned on by default. Azure availability resources as availability set, proximity placement group, and virtual machine scale set can also be configured. Beyond that, you can delete them or create them, even when they do not exist in the source resource group. For example, you can move VMs to a new availability set. Let's have a closer look at the RGCOPY log file. The file consists of many sections. The first section contains data about the system environment, source and target resource group, and the required RGCOPY step. The next section contains the disks and VMs of the source resource group. The section about RGCOPY tags is only needed for workload automation. Please check the RGCOPY online help for details. The next section is written during ARM template creation. In this section, you can see all resource property changes that were performed by RGCOPY. In this example, the size of VM HANA1 has been changed, caused by parameter set VM size. The skew of all disks has been changed, caused by the default value of parameter set disk skew. However, RGCOPY double checks whether this is possible or not. RGCOPY automatically corrects some resource properties that would result in deployment errors. For example, premium SSD disks are converted to standard SSD disks if the VM size does not support premium I/O. Accelerated networking and write accelerator are disabled if not supported by the VM size. Read-write caching is disabled if write accelerator is enabled. However, you can disable all automatic corrections using an RGCOPY switch. The next section contains the disks and VMs of the target resource group. RGCOPY calculates the number of CPU cores by VM family needed for the deployment. If this exceeds the subscription quota, then RGCOPY stops with an error before trying to deploy the ARM template. The next step is creating the snapshots. This is done in parallel using many PowerShell threads. After that, a list of all snapshots, including timestamp, is displayed. Finally, the ARM template is being deployed. After that, the log file and the ARM templates are saved in a zip file, and RGCOPY ends with either exit code 0 or 1. Now that we know what RGCOPY is, let's talk about what it is not. RGCOPY is not an SAP deployment tool. It simply copies the most important resources of an Azure resource group to a new resource group. It does not change anything inside the VMs, like changing the server name at the OS level or applying SAP license keys. On the other side, you can use RGCOPY even for other non-SAP workloads. RGCOPY only supports the most important resource types that are needed for SAP, as VMs, managed disks, NICs, and load balancers. It simply ignores unsupported or unknown resource types in the source resource group, for example, a storage account or an Azure Cosmos DB. You can find the list of supported Azure resources in the RGCOPY online help. RGCOPY is based on a single resource group. All copied resources are stored in the target resource group within a single region. There are few exceptions. For example, you can copy a VM that is using a NIC or a subnet in a different resource group. However, everything ends up in a single target resource group, with no relation to other resource groups. RGCOPY has lots of other features that we did not discuss yet. I did not show you how archive mode and update mode work in detail. Let me list a few additional features. For Linux VMs, RGCOPY can convert Azure NetApp volumes to managed disks and vice versa. You can merge a VM into an existing resource group. I'm using this feature for copying a pre-configured jump box into a new resource group. You can clone a VM inside a resource group. This is useful for duplicating application servers. Keep in mind that renaming the VM on OS level must be done manually in a separate step. You can skip VMs and disks separately. We are using this for skipping some SAP application servers when the VM size of the database server is reduced. You can start scripts inside the VM after the deployment in the target resource group. This is used for starting SAP and an SAP benchmark. These scripts are not part of RGCOPY and have to be developed on your own. Finally, you can install some Azure VM extensions, even when they were not installed in the source resource group. Thank you for watching this video. Stay healthy and see you soon at SAP on Azure.